Yeah, so hi folks. Welcome to BS&BEER Canada for the February edition. I'm Lorrie Rand, and I am doing my best not to sneeze and cough at you all. I am under the weather tonight, but I'm excited to be here for this talk from our guest, who I'll introduce in a few minutes. If you don't know me, I am based in Halifax, so just over there. I did it right on the first try that time, you guys. I'm getting better. Usually a little I'm always kind of right shoulder. And because I'm sick, I'm just drinking a cup of hot tea. So no exciting beverages on here on the east coast of Halifax for me tonight. Um, yeah, and I missed last month's show, so I'm happy to be back. And we've got Sean and Jeremiah here too. So I'm going to hand it over to Jeremiah, going east to west.
Good evening, everyone. I'm Jeremiah Summer. I am a builder in Ontario. It's right back in behind me there. I thoroughly enjoy the residential construction world, and I like to tinker and learn building science techniques that help us improve our enclosures and help train our young staff in some of the disciplines that I think they will need to know going forward in the future. So it's a very enjoyable process for me to learn and learn from the various people that we have on here. So I'm drinking a Sober Carpenter cider this evening, and I will pass it down to Sean.
Good choice. I love a good cider. Good evening, everyone, or good afternoon, depending on where you're at. I'm Sean Sainamore, manager of Revive here at Etro Construction, where I get to focus on retrofits. And so, yeah, I guess
Mm.
about there. And I love how small this world is because I get the pleasure of meeting Ben a few years ago when he was in Vancouver. And unfortunately, he's decided to cross the country from one coast
Um,
to another. And I
Fortunately
do
for
look,
the East Coast, though.
yes, and I do look forward to see him in a 3D form when I do make the trek out to Halifax later this year. So that being said, is unfortunately I ran in and you can't see it, but that is just straight up H2O. But I will keep us updated because I think you guys can see this. This is my
Mhm.
indoor quality monitor in my
Yeah.
office space. That's not great. But I will keep track of it and see how much hot air I keep blowing into the space, and we'll see how this works out. So I'm glad to see some smiley faces, and Lori, I'll send it back to you so you can give an intro of
Yeah.
the legend Ben.
All right. So Ben Reed is a resilient and versatile product leader, now living here in the city of Halifax, actually Bedford, I think, with 10 plus years of experience leading multidisciplinary hardware and software teams through the development of IoT products. And I'm like, is that IoT really, or is it IT? And I'm just being dumb. Ben's journey in building science started with 4 years at Haven IIQ, based in Vancouver. And he developed or was working on an IAQ platform, designed for residential HVAC contractors. And Ben is now a principal at Tealmaker Consulting, and their mission is to transform residential building market through innovative technology, engaging content, and human-centered processes. And so Tealmaker's clients include top influencers in the residential mechanical industry, such as Energy, Vanguard, MeasureQuick, and HVAC Know It All. And me too, Ben. Uh, uh, and outside of work, Ben splits his time between his family and automating his phone for fun, his home for fun through open source hardware and software. And that's what he's going to share a bit about tonight. So, Ben, handing it over to you. Uh, Tell us first what you're drinking and give us a welcome, and then you can share your screen when you're ready.
All right. Thanks so much, Lori, and thanks for the rest of you guys who host this show. I've seen it a couple times, and I really enjoy the kind of effort that you put into this, and that there's all these nerds that just love to spend all this time hanging out. I used to spend a lot of time in hacker spaces, and so this is kind of like a virtual version of that, just with a building science twist. I love it. I am drinking a Corona Zero because I just don't do alcoholic beer anymore, and it was the only one in my fridge, so that's what I got. Cheers. All right. Well, do I go right into presentation, Lori? Yeah. Okay.
Yeah, go for it. You have lots to share, so
yeah, I'm just
might as well dive right in.
come on. Where's my? There we go. Sorry, guys. I'm just getting this reset up because it decided to not do what I wanted.
No worries.
Okay.
I can do filler. So the rest of our BS and crew are down hanging out with Minnie and Mickey Mouse. With some of our other BS and Beer friends. There's a big event on Wednesday, which will be yesterday. We're great to see the BS and Beer community get together in the Hewer booth to cheers and get connected, which is great. A lot of lovely faces. And so yeah, a few of our friends are down there, but we're here in the Great White North. And there you go, Ben. We can see your slides, so kick it off.
All right. So the title that I gave this is basically just building envelope monitoring with open source sensors. Um, and this is probably a project that a lot of you are familiar with because Lorrie has presented on it before. And so if you're not familiar, you can go back and see some of Lorrie's previous work. I think it's probably been recorded. I think so. I think
It
even at
is.
the heat
If
pump
you
symposium, you did a session. I recorded it and then I edited it for HRAI, so you can find it on the HRAI channel.
That is cool. And yes, BS&BEER's YouTube channel does have some previous info about this project.
Oh, and I see Aaron Smith in the audience too. Hey, Aaron. He's also local, Halifax.
Hi, Ben. Thanks.
So we'll have kind of, I guess, five-ish sections here. Starting out with the overview about what, just kind of the background on the project and the technology that I used, and then the implementation challenges. Going to go dive into some of the data where I surprised Lorrie because she hadn't seen it much yet, other than a couple of previews, and then the conclusion and next steps here. So. Yeah, as Lorrie said, I've been kind of my background. I'm actually telecommunications engineering is my original background. Then I got into product. I joined a hackerspace. I got really bored with just doing telecommunications work. I wanted to get into product development, and then I became a principal investigator at Southern Alberta Institute of Technology, where we got grants to do product development with small businesses across Canada. And it was a lot of fun. I got hired by one of those businesses, incubated by General Electric during their phase when they were trying to do the Internet of Things for the industrial space, which they failed wildly at. It was really fun to see that dumpster fire burn down. I had front row seats to it. A lot of money was wasted, but I got to play with robots and drones and stuff making digital twins. So, which I think probably some of you in the building space have played with is point clouds and dealing with the uh, um, anyway, some of that technology now you can just do it with an iPad versus some of the stuff that we were doing at the time in that startup. So it was really cool. It was really fun. But then I moved out to Vancouver, joined a indoor air quality startup where they made the only duct mounted indoor air quality sensor. And it was a solid state sensor. They had a bunch of patents around it. They had deals with Daikin, who white labeled the product. They still are around. They've scaled back some of their efforts because product market fit with that product was a little bit difficult. So you can still get the Haven indoor air quality monitor for their in-duct solution, but they have a room monitor, which is also pretty good now. But yeah, once I moved out here, I left Haven, and I ended up we did some work with uh, a company called MeasureQuick. So who here has heard of MeasureQuick? All right, yeah, a couple of people have, but so MeasureQuick is like basically the only residential HVAC commissioning solution on the market. Because if you guys have done residential projects and worked with residential HVAC contractors, the equipment is rarely commissioned unless you're working with a really, really good contractor. But very rarely are those it is residential HVAC commissioned, just because up until recently there's never been a point. Like there's always been, the manufacturers had such a slot factor built into those old like PSC based systems that you could just slam it in, start it up, and then as long as it's hot and cold, then it's good. But now with all the A2L and the variable speed systems, the slot factor has gotten so small that something like Measure Quick is kind of required. So I do consulting with them. I do consulting for HVAC Know-It-All and also Energy Vanguard and Lorrie as well. Love it. So I'm also a huge fan of open source. So we'll talk about that a little bit later. Talk about Home Assistant, which also, has anybody here heard of Home Assistant? Great. Have you used it, Jeremiah? Oh man, you're missing out. Anyways, we'll get into that. So let's talk about the project. The project that this is mostly Lorrie's project. So for these next couple of slides, I'm going to tag her in to talk a little bit about these, the background, just to kind of give us the cliff notes about what this retrofit was for, and also what they were trying to achieve.
Yeah. So this is an 1850s era house in Halifax's North End that my business partner and I bought because we spent many years trying to talk clients into doing passive house retrofits, and nobody did it yet. And so we wanted to, have that experience, and we desperately needed a new office. We probably should have looked a few years earlier in hindsight, because the retrofit took a long time, but that's another story. And so it's, so the work started in the middle of 2022 and just finished up in spring of 2025. And we kind of made the first and second floor only the passive house enclosure, because the basement was a scary spider cave kind of scenario. The building had a blower door, or an air tightness of 24 air changes per hour when we first bought it. We actually haven't done, we have one final thing to do that we know is a leak, and so we haven't done our final blower door test. The last blower door test we had was 3.5 still, so we still have a little ways to go from our target, which is 1 air change per hour. And in terms of the heating demand target, we're pretty much there. We need like maybe a couple more points from the air tightness to get all the way. But right now we're sitting at an 86% reduction in our heating demand. So that's pretty great. Yeah, and we did the whole project with low carbon insulation, primarily cellulose, except for a little bit on the roof. And that is going to feature in this story in a little while. So stay tuned.
Yeah, there's a whole reason why kind of Lorrie was looking for sensors, is because the cellulose insulation is a untested technology out here that basically nobody knew how to work with, at least in this part of the country. So understanding, measuring it after the fact is what we wanted to do here. So with the sensor side, maybe if you could talk a little bit about that WIF or WUFI condensation risk.
Yeah, and I will say, so people here, just to clarify slightly, we have lots of cellulose in walls, but doing cellulose in an unvented roof is a big fat no-no, and it's because of the risk of condensation happening on the sheathing. So usually, we also don't do unvented roofs with batt and other insulations because they're risky. And so our roof assembly was a 14-inch TJI stuffed full of cellulose with a variable permeability vapor control membrane Intello Plus on the ceiling side, and then there's a layer of sheathing, and on top of that there's tapered polyiso insulation, and it kind of that gives us our roof slope, and so it's sort of at the smallest it's 4 inches, and it tapers up to something, I'm not really sure, and that the the smallest number of that insulation of the polyiso was determined using using Woofy Pro, which is a modeling program that will identify, like you can kind of do a static dew point risk assessment and know that there's a problem. And then if you can't get rid of that problem, you bump up to a dynamic model which is Woofy, and it like kind of looks at every hour, what over 5 years or something, over the weather pattern for your location, what is the moisture risk on that spot, on that assembly. And so above 4 inches, our roof in theory is condensation proof. So for that, yeah, I think that I could talk all day about Woofy, so I better shut up so that Ben gets to talk.
Well, good. I am not a Woofy guy at all, so I'm glad that you're here for that. And so here's kind of the floor plan. We're going to show you both the second floor and the main floor. And Lorrie, if you could maybe also provide some commentary on why you chose the locations that you did.
So we did this partly we did this because I knew Ben and I was kind of like, hey, could we do some sensors? And totally because I wanted to provide some evidence about what was going on in the roof to myself. Like we had the modeling, but modeling is rarely 100% accurate and perfect. And it was also just an opportunity to sort of test out, the what's going on in the walls and the other assemblies as well. And so I came to Ben with a little, idea of I'd like to look at a few spots in the roof, and in this case a north arrow would be helpful for you guys, but basically the back half of the building, so on the left hand of the screen is the back, which faces south. So you can see just over where the arrow that says comms closet, there's a beam, and that's kind of where our roof ridge is. And then so the front side is north, the back side is south. My theory was that the north side might be risky and the south side would be fine. But that I wanted to kind of just have a few sensors in there to see what was going on under that sheathing. And the part that is the little L, it's the structure. So the front structure of the roof is just like that part is maybe 2 feet higher. So that L kind of that little box drops down a couple of feet. And so the structure changes a little bit there. So it was important to me too, to just, check the south and the very far south parts of the roof.
And then on the main floor, was there any special reason why these locations were chosen?
I wanted to, so there were a couple of things. I wanted to monitor the walls on both upstairs and downstairs. Again, that star you're looking at now, that's the north wall. I sort of wondered if the north side might experience different conditions than the south. And then the star that you see at the kind of intersection of the back bump and the main house, there had been a leak there. We chased that leak all through construction. Like there was like some kind of tricky thing happening there. And so we were just kind of like, this is a vulnerable spot. We want to know if it ever gets wet.
Yeah, I'm sorry, but the annotations were wrong on this one. But
oh, oops.
All right. So one of the first kind of, I guess, conversations we had about this was, could you help me select the sensors? So that was the original scope of this, is that you had been in contact, you had done a little bit of your own research, you had reached out to a couple of companies that make, sensor products. I think even like the Hobo onset was considered here, but I didn't put it kind of on the slide. But these were the ones that I was kind of going through because I have a lot of familiarity with the first two. And then the last one I did some research on, and it looks like it'd be a great solution. Like from SMT Research, that's all they do as far as a product. But my agenda was to use this as a bit of an excuse to show off what Home Assistant could do. So for this project, kind of the opportunity to play around with kind of an implementation that I've never done before, which is putting all these sensors in walls. I've sensors throughout my house for a lot of different things, everything from radon to just custom, like using a ESP32 device and kind of building out my own either actuator or sensor for kind of doing whatever I want, depending on the project at the time. But in this case, we wanted something that was not too expensive, but would just be able to be in there long term, no batteries, because we didn't want to have to deal with the maintenance, and also just wireless in general for something that might be, kind of lodged somewhere that you can't access after the fact, that probably is going to have its wireless signal blocked quite thoroughly from the materials. That cellulose materials would probably impact the signal quite a bit. That's why I had proposed Home Assistant, and also just because I wanted to kind of do the experiment myself to kind of see what this is like. Now why can't I get rid of the little annotation? Okay, so that annotation might just be there now. I don't know if there's like a undo button. No. Okay. Anyways, so on to the Home Assistant. So for those of you that are aware, it's a really, really capable tool. It is one of the biggest open source projects on the planet. It is compatible with almost any hardware, so you can run it on a $30 like mini computer, like a Raspberry Pi. That's what I have at home, running it all the way up to, we can put it on a virtual machine inside of a server, and so it can literally connect to anything, like anything you want, whether it's the your smart fridge, your thermostat, or like I've been doing custom sensor integrations. That's the being one of the most active open source projects on the planet. You can find examples for almost any type of project that you could ever think of. And there are oftentimes libraries that are already pre-made, that if you want to connect something, that's maybe if it's an atypical sensor that has a serial output that you just plug it in via USB and has a serial output that you can capture, you can easily just write your own, or have grab a script from somewhere to be able to have it parse that data coming in, and to be able to add it to your database and to do whatever you want with it, whether it's data science, or if it's automation, or just data logging. There's a lot of different applications that you can use Home Assistant for. I actually have a podcast episode on my Tealmaker YouTube channel where I interviewed the founder of Home Assistant probably about 3 years ago. And I posed the question of being like, hey, so can we use this commercially? Can, let's say, a building science practitioner like be able to use like these little Home Assistant devices, like let's say deploy some of these as data loggers on projects and then charge for them because it's open source? So it's like, is that okay? And his answer was absolutely. There is like the licensing model of the software allows you to use it commercially. And so you can even put your own skin on it if you wanted to have kind of a custom interface, and like you could build out a home automation system for a client, and it could be your own branded home automation system if you wanted it to be. Although that's a lot of effort. So I'd say just spend some time playing with it first before trying to do something like that. But I really respect what they're doing because they are kind of fixated on having fully local control, where you as a user, like all the big providers are going towards cloud, like, put everything in the cloud, like just connect this thing to the cloud. They've gone the other way and saying that we don't trust any of those cloud products because so many of them go to business, where like, and then, or else they get bought, and then they get like what the data now, the privacy policy or the terms of use that you had originally had with that, let's say a small company that you loved, now says that your data is being used for other purposes. So kind of myself as a bit of a privacy geek, I really love that Home Assistant I don't actually have to connect to the internet for it to work. And it has like, it just kind of I'll show off a little bit of the functionality of the interface in just a little bit. what you'll see in my demo is basically just a shadow of what it could be as far as the interface goes, because I've only used it for this project for a data logging purpose for the most part. But it can do it can do your psychrometric charts. It can do data science directly inside of the interface. You have all the different protocols for like pub sub if you have those types of sensors. And there's a lot of educational institutions that are actually even using it, whether for teaching uh, or for actually doing automations of some of their buildings. And so we have a couple case studies about how Home Assistant is being used, by practitioners around the world. So here's an example of somebody building an open source BMS system at it was in Taiwan, and they achieved a pretty massive kind of reduction in their what was it? Yeah, so the cost was about 10 times cheaper than it would have been going with an off-the-shelf commercial solution, and they were able to achieve all of the objectives that they wanted to be able to automate and optimize an indoor environment here with basically the same type of uptime that you'd expect from a commercial system. And another one, which this one here is a case study from the UK, which also was an retrofit project. I'll add links to these in the chat after I've done my presentation, that kind of give you access to seeing. You can take a look at these web pages that kind of showcase these projects. But it's really interesting how people all over the world are using Home Assistants for building science already. So for our own implementation, we had the hardware stack that I had selected for this was a solid state Raspberry Pi. So because it's the Raspberry Pi Foundation has all these different variants of the little kind of piece of hardware. I'll show you the one that I chose in an upcoming slide here. But what it is it's an industrial little server that looks like what you'd find in a PLC box. And then we had the sensors, which all together they were actually quite cheap, so like $400 for all of them. And this is I'll get into the sensor in a bit, but altogether it was below just for the Raspberry Pi, the sensors, and the other kind of interfacing hardware. It was less than $1,000. And it was for 10 sensors. And then we had some additional supplemental stuff that I had added to the bill, which was the AirThings View Plus, which probably some of you have used. It's one of the best indoor air quality sensors that are out there. So I could get some supplemental information, the upstairs, downstairs environmental data, to be able to compare that to the in-wall data. So how many of you play around with sensors as a part of your job? Nope, nobody? Okay. So maybe I don't need to go into too much of the detail, but as far as selecting a sensor, the reason why I selected this one, it was that the cost was reasonable, but these kind of the ranges, the performance of these sensors were basically right spot on what we were looking for as far as the accuracy and the resolution. So, and a lot of flexibility in how you install it, because RS-485, it is a protocol that allows you to kind of daisy chain a lot of these sensors together. And it's used in industrial settings all the time for, factories and building automation. So it was, for this particular purpose, it was perfect. And the other piece of hardware, so that's what the Raspberry Pi industrial computer looks like, and it is probably just a little bit like, if you can kind of it's a little bit smaller than this mini PC that I have in my hand, so really small, basically only use about 10 watts, but it's running Linux on there, and you can access it and manage it through a web interface. So locations that we ended up getting the sensors installed into were slightly different than I guess, proposed locations were. And now, so Lorrie, is there any kind of commentary that you have on, the why we ended up settling with these specific locations?
Yeah, I mean, in part, I think it's the same logic, looking for, a range of places, again, front and back roof. We ended up I kind of started out with these are the bare minimum, and then we just added a few more. Like, I think I started out wanting like 5, and I think we went to 10.
Yeah.
We could have did a whole lot more. Yeah, and actually we also added one in the basement as well. Forgot about that. It's good. I haven't looked at these in a while, so thanks, Ben. Yeah, and again, I think, maybe some of them moved around a little bit only for logistical reasons. Like, it was a little bit easier to get like the wire to run the wires, but more or less same strategy.
And we'll get to the challenges in just a little bit here, but myself, as I was kind of helping out with this project, the contractors that we were working with, of course they didn't have experience with the sensors, but they also didn't have kind of experience with any kind of building automation stuff. So it was a really hands-on experience for myself, where I had to be providing a lot of guidance on how to, so providing all these additional diagrams and instructions for the contractors as we were doing the work. But what you can see in this picture is that they had like behind that, if you've worked with the cellulose, that's where all of the cellulose was going to be piped in behind oh man, my brain is not working right now, whatever that material is.
Cellulose bib.
The bib. So yeah, behind the bib there. And so we were cutting holes in the bib to get the cables kind of placed properly. They had placed the majority of the cables before we put up the bibs. But because there was lines crossing the communication, we had a couple of rework exercises that we had to do throughout the project. So these are some pictures of where we were of what the sensor locations were, like where we were actually putting them. So like, but we're kind of mounted right to the wall here. Another one, this is kind of where I was standing before, where kind of on the wall here is actually probably on that wood right there is where we had put that one. And then this is that roof up in here where they were going to be putting that cellulose installation. So, any questions on the sensor placement? Yeah. So I can try. So this one will require me. I might do this at the end, where I try to go into the Home Assistant dashboard, because I actually have to VPN into the site because there's an IT thing I have to fix. Anyways, I'll go into challenges now to kind of just give you a little bit of background as to how the project had encountered quite a few extrapolating circumstances that made it difficult to get it done within a timely manner. So I guess, Lorrie, if you wanted to provide a little bit of color into this interesting timeline.
Yeah, so I mean, we had lots of issues. Our site is a very tight urban site, like old residential neighborhood. It impacted things like deliveries, and if they sent the wrong truck, we would have to send it back, that kind of thing. So there were lots of logistical challenges with the project. There was also Ben has here that there was road construction between September and October of 2024. It went on a lot longer than that. Random road repaving happening around the neighborhood, and sidewalk replacements. Really unlucky. So just yeah. And then we would start with one kind of electrical guy, and then a different guy would come the next time, and so there was just like a lack of continuity, unfortunately, across some of that. So just issues, that regular construction issues, but they were really annoying.
Yeah, we kept missing our window to basically find the right person at the right time. And there's a couple of times where basically the sensor wiring was had not been done to the spec, and so a lot of troubleshooting. And it just yeah, lots of pain. I don't think like because we probably have about when is it top of the hour when we're done this?
I mean, we can go a little bit longer, but that's the aim. Yeah.
Yeah. So let's dive into the interesting stuff here. So the data analysis. So we had out of the data that I kind of pulled from here. I only have the last 90 days of the data from the site. And so that's about 1.4 million data points across like the temperature, humidity, dew point, but also additional supplemental data from outdoor and the indoor IAQ sensors and the thermostat data. So there was a couple, like as you see, S10 and S8, they ended up having wiring issues. And so one of the big learnings is that you have to make sure that you're working with somebody who really knows how to do the wiring instead of playing hot potato with that side of the project. Um, it so what you see here now is for the connected sensors. Here's the breakdown from the kind of most warm until the coldest sensors. The first one being in the occupied space. So we put one sensor that is ambient, kind of, on the second floor, that is not inside of the walls. And so that's what that first one is. And so on average, that data of 19.5 degrees over the last 90 days is what that reading is from. So from this, you can kind of make some inferences about how well that cellulose insulation is working on the temperature side. So Lorrie, what did this? We're going to get into humidity in just a second here, but let's
Yeah.
talk
So
about the temperature.
I mean, definitely, and generally speaking, the cellulose that was or the sensors that were in the walls, it wasn't like right hard on the outside of the sheathing, or it was kind of stuck to a stud, and maybe middle it wasn't too bad, but we were putting the sensors on the roof right at the sheathing. And so basically, some of those ones that are in the kind of 13 range, those totally make sense to me because they're in the middle of the insulation, halfway to inside to outside. The north window, that's getting a little cold. And then those last three, like the south hallway and the west window and the wall, that's the one at the intersection. And so that's basically where these are. I can see the pathway from where we had water come in, that basically there's the water came in and got things wet and it's never dried out, is my interpretation of this. And yeah, and then thank you, Ben. This is the part that I'm like, no. I was like, I don't. Can we cancel the show? But so those last three that are quite vulnerable that I was just talking about, like almost like one's at 100% relative humidity and the other two are 95. That is not good, considering this is like an average over like the last 90 days has been wet for the entire winter, basically. So I need to and we actually had somebody booked to take another look at this in November, didn't come, and now we gotta wait, unfortunately. So the lesson I'm learning here is to make a bigger stink about people showing up, because this could be, there could be a lot of wet stuff up there. There's no like the other thing that I kind of go in those areas on the inside and I'm like, oh, as like I have been kind of watching them to see if there's any signs of water, because I was worried when they weren't able to fix it before winter really set in. There's not any interior signs, which makes me cross my fingers that my Intello is doing its job and that it won't be as bad as this looks. So I'll stop talking and let Ben talk more now, but I'm truly horrified.
Yeah. So again, sort of highlighting, emphasizing the potential danger of that information there is that the dew points that were basically cross, like we're the entire time we're across the dew point, and it's probably not good. So I don't need to beat a dead horse here. Um, Although this next slide is still beating that dead horse in demonstrating that the if you look at the sensors that are within normal ranges versus the ones that are outside, there never was not even on an average. There weren't times where it would drop below. It was just always above. Um, so another interesting one is this kind of indoor versus outdoor correlation, where those two, like the ones that are in the sheathing up on the roof space. So here's this data up here is one of the indoor occupied space sensors. The ones kind of that are mixed into the outdoor, this dark green, and sorry about the colors are just not great, but the dark green is the kind of outdoor air averages from local weather stations, and then the lighter green and the yellow are the ones in the sheathing, and so they're essentially outside from what the data shows. And then so this part's interesting because Lorrie had kind of made a comment about how when there was the polar vortex, something happened in the building, and so I did a little bit of additional spelunking and found a kind of created a bit of a timeline on the data, which I'll get into the process here because if you're a building science nerd that loves to look at data, you're gonna love how I did this. But first, I guess, Lorrie, we can kind of provide some additional commentary to this. Is that this was kind of where the ecobee was showing heat mode
Yeah.
in this red block here, and then it was still in heat mode, and then it just decided to just not do heat mode or anything. It just decided to stop, and there wasn't a power outage because the data would
No.
have been gone if there actually was a power outage.
So yeah, and so you can notice, so the blue line is the outdoor temperature, and so you can see in the daytime on kind of January 23rd, between then and dropping into nighttime over between, I don't know, over 24 hours, it went from hovering around 0 to -15, and then up a little bit the next day, and then down even colder to -17. And so I woke up on Saturday morning to a message that, it was something like 14 degrees inside the building. And I was like, what the hell? 14 above 0, but still, it was quite a shock. And I sort of went into there was not much that I could do because it was the weekend. Went and checked and looked at everything, and to my eye, everything was fine. And then annoyingly, we had a blizzard Sunday night into Monday. And so it was Tuesday before we could get an HVAC technician to come in and check it out. And what had happened was that when the heat pump was, I'm going to say commissioned, it was not commissioned. Back to one of Ben's earlier points. It was just kind of the auxiliary heat was set to shut the heat pump off entirely when the temperature outside got to -15. And so basically it just stopped working because it was set to do that. So I'm very relieved that that was what the issue was, and that it wasn't something that that was unsolved or much more expensive to solve. But it was a tense few days for sure. And you can see it got down to about around 9 degrees Celsius in the one location where the sensor was inside. So pretty darn cold in that room, in that building.
Now, was there any other heat source in the building?
So no, I mean, we didn't put backup, go Lorrie. We actually do have an electric fireplace, and honestly, we didn't go. I could have went in and turned that on. It probably would have made things much better. But I was like, I don't know. I was like, I don't know what's going on here. We'll just like turn everything off and it'll be fine. But then I chickened out and I went back and I put a space heater on the concrete floor where our kitchen has a concrete floor. So we put a like small electric space heater in for, and that ran for like from Sunday, Monday until we actually got the guy in there. So there might, be a little blip in there. Yes.
So then this was when the space heater was brought in. And then this was
Yeah.
just that tiny little space heater was keeping that whole building during the was it almost down to so probably
Yeah.
it was still below 10 for a good chunk of that time.
Yeah. Overnight it was those nights, it was
Well,
like
-10.
minus 17, minus 18. Yeah.
So at least the insulation in the building was actually working, and you solved the leakage problem. That's what that's what those numbers show you.
Yeah.
But anyway, so it's just like again a bit of a commentary. My when I look at the data and take a look at kind of do a little analysis, to me it reinforces the value of the necessity of commissioning, because like how many of you that have a heat pump in your house actually know that the refrigerant charge was set properly? Did you get a report that told you that that your heat pump actually has the appropriate amount of the refrigerant in it, or that your ducts have the appropriate amount of airflow if you have ducts? Like a whole bunch of so many elements about like how in commercial you spend so much time like bigger commercial projects, you spend so much time in the commissioning process because there's a lot at stake and there's a lot of stakeholders and reasons why you have to. But residential, it just has been such a fire and forget that this is a another reminder of how important it is to get that equipment properly commissioned and having proof that it was commissioned. And also that monitoring is actually quite it's so inexpensive now, even with an ecobee. Like the fact that you got that notification, that those are pretty kind of standard practices now. Like almost everybody has a smart thermostat. So a couple more pieces of kind of information here is just kind of looking at the indoor air quality of and the HVAC performance. We like there wasn't, besides the ecobee thermostat, some of the other elements of the heat, the ventilation system and the air system is not really being monitored. I have a whole bunch of options for that we just haven't added yet. So maybe throughout the next couple of months, Lorrie, we'll kind of add another kind of package of sensors across the various elements of the building so that we can get even more data.
But you can tell the 2 dates that we had Christmas parties there.
Yeah. Yeah. So, but in general, this passive house, which is fairly well, sealed now, you're on most normal days, you're still staying below 800 ppm for the CO2 levels, and just a couple of spikes for the IAQ. So summary of the data findings of and probably I can provide this or maybe a version of this presentation, Lorrie, to people that need it in some sort of a link afterwards.
Here, I'm gonna put my email here, and anybody who wants it can ask me for it.
Yeah, and so for us, I think at least some of my conclusions is that the hardware is appropriate for monitoring these types of projects. And we are only using a fraction of the capabilities so far. The everything's in the execution though, where if without finding good help that can do that type of work, relying on a kind of some of the stakeholders that are involved, they need probably a little bit more training to understand the implications of the work that they're doing. That the HVAC system, you've got to make sure that it's commissioned, but that even with some of the sensors falling offline, we still got a fairly useful data set out of them, and we're going to continue getting a lot of useful data out of them here. So, Laura, did you have any other kind of conclusions about what you're going to be doing with kind of what your next steps are going to be
Oh,
for this.
well, it's just a sort of reinforced what I knew for the next steps, but put some more urgency behind them. And it's funny, I typed in the text. I lied to you because we do have in-floor heating in our front entry, and we
Okay.
were supposed to have some extra heating, additional heating in the kitchen that didn't get installed, and I just didn't want to throw my builders under the bus. I got to think about that. We definitely need more backup heat than a fireplace, and some in-floor heating. So.
Okay. Yeah,
Yeah,
but so then the in-floor heating was active the whole time.
it was. It's not, but it's a very small area, so it
Okay.
barely counts. Yeah.
Um, Sorry, Lori, I think, was there any other kind of conclusions that
No,
you, or
I
takeaways
mean,
that you
I
had
think
from
that
it?
I'm just really excited to like monitor for a longer period of time. Like this, this was a little bit dramatic for me, but like, like I think like our ultimately we're going to have like the kind of stats on on a tablet on the wall in the office and just be able to point at them anytime we want to and really stay on top of things. And I mean, the reason we want to do that is for us, but it's also so that we can show other people that they have this option to be able to have fairly inexpensive data available to them about how their home is performing.
Yeah, and so for me, there's a bunch of like to-dos on the software side, and especially since the like I had originally set up the system to pipe data out to a much more robust database that I would have in the cloud. But because there was a whole bunch of there's almost a month that we had lost power to or at least a week or two that we had lost power to the whole building. And so there's a couple of my configs that had been reverted, and I didn't catch the changes in time, so we just lost a whole bunch of the data, unfortunately. But I think that after this presentation itself was a good kick in the pants for both Lori and myself to be like, right, we gotta make sure to properly review this data because we booked ourselves in to talk about it today. So really happy that you guys were here and paying attention. And I do have a couple other supplemental slides that I could tell you about my process for creating the data.
Or I think you should do that, but you should also not forget to show the actual demo. Um,
Yes. So
and
the demo
yeah,
itself, it might knock me off the
okay.
connection here for just a minute, but it shouldn't be too bad.
While you do that, I also want to just say, I don't think that this is, I mean, I did this because I wanted to provide evidence on vented roofs with cellulose, but also all I've really proven is that 4 inches of insulation outboard of that is not sufficient potentially. Um, Maybe not even that because I know that it was there was a known issue in that part of that area of the building where those sensors because I still would have expected to see more of an issue on the north. And so I'm really I kind of want to dig into it a little bit more. Like maybe 4 inches is enough, but yeah, it's more Lori hired the wrong roofers.
Hey, Lori, while Ben's just switching out, just a question about the roof. So is it
Yeah,
4 inches slow package, all one material, or is it different,
no,
like two different pieces that you could overlap? Just because I'm worried about the
yeah.
joints and how the joints were dealt with.
There are multiple layers of it. So there were 2 inch lifts and then, tapered up to I couldn't tell you, I can't remember how much it tapered up to at the peak because of, whatever slope we needed to get. Um, and really what I think is the issue is not the main roof necessarily, but something at the junction. There's just something goofy that happened where they came together. Very good. Yeah, where the end of Ben's fingers are, where the sensors are. So
Okay.
yeah.
Such a great presentation, you guys. Thanks for taking the time to just unveil the data.
That's super cool. I've been wanting to do something like this in projects for the last few years, but just haven't sort of made that move. It'd just be so interesting to see how things react at different times of the year, in particularly in walls, because we don't do a lot of
Yeah.
Yeah.
um, unvented ceiling
Hmm.
applications that often, but
Yeah.
that would obviously is a really interesting spot to check. course.
I'm also trying not to panic. Same thing with like, I did panic a little when the heat like was like, where the hell is the heat? The things that, stuff like that, the first winter of a building, things like that do happen sometimes. And with assemblies, you could have things happening invisibly for years and years without any evidence. And so this just like gives us the evidence to take action right
Well,
away.
and you could sometimes have things sort of happening that are just maybe not quite as like we don't see how severe or not severe they might be. And like we've torn apart walls that we think should be like a real mess and they're not as bad as we think. And then we've taken apart some that we expect to be, perfectly fine and there are issues. So sometimes I think it's sort of you need a bit of time to sort of let things sort of average out in a reasonable way as opposed to like sort of small sample sizes.
Also, I have to confess, like the room where the closest sort of office to the leak is where is my office. And I was when the leak happened, I was like, should I just put a big heater on and just leave it? And I didn't want to because I didn't want to be too hot.
Did did the leak happen after the roof was insulated?
Yes.
So it could take a long time for that cellulose to
Hmm.
effectively dry. Like
No,
even with a good
I know.
membrane in there, like
Yeah.
I suspect that would be a fairly lengthy process because it can only dry one direction. And if
Mhm.
you've got 14 inches of
We
material in there, that
But
could
we
take a while.
didn't really know the extent of it. Like
Right.
that's the thing. Like we sort of saw it like really close to the kind of corner and thought, oh, that could be leaking. But now I know it definitely was more than I thought than I was hoping that it was. So yeah.
Have you looked at it with a thermal camera yet to see if you can see
Yeah,
any
I've looked at
cooling?
it with a thermal gun and I can't really see much. So that tells me that the cellulose is spreading the moisture through.
Mhm.
I
Good
think,
question.
or that it's just at the sheathing and the cellulose itself is fine. That's
Right.
either one or the other.
Yeah.
And maybe that's the same thing.
Hey, there's a
Yeah.
Thermal Thursday that really would like that picture to be posted. Just saying.
All right. I'll see what I can do. What I do is I take like a million pictures with my FLIR thing and then I don't remember exactly where I was later.
I
And
know.
so it's like, oh, is that there? So gotta get better. Again, I need a better system for that. Maybe Ben can sort me out. It's very, very organized.
Well, I'm not organized. I like to tinker. Um, so anyways, do you still see my screen?
Yep.
Yeah.
Okay, so what I've been doing is I've just been throwing together a couple of I guess visualizations looking at some of these devices that are shown here. So it's a very flexible interface. It even has like a full kind of energy monitoring. So if you have solar, if you have other renewable sources, and if you're measuring, let's say there's a lot of different kind of little widgets and devices that you can use to measure inputs and outputs from your home. And technically we have one of those installed, but I haven't been able to configure it yet. Where you can kind of pull all of your energy data in here and see a kind of a real-time visualization of that data going back and forth from the grid. Let me see if I have my own. Can I access my own Home Assistant? No, not until I go off the VPN. Okay. Um, but it kind of gives you like an entire like all of the different things. So this is just like the ecobee data. That it's if I was to take a device that is the connected to the Home Assistant server here. So yeah, ecobee is a great example that all of the sensor ratings that we can get, it kind of shows it in its various formats where these are binary sensors of being able to show like, on or off or motion, no motion, home or not home. And then being able to show heat or cool kind of in this interface, which like this is specifically the history interface where I can set my um, set my time frame here. And if I wanted to choose like a longer term thing, it'll pull all of the data and show you that, so you can explore it and analyze it. Another, like I'll say, the things product. I think on the second floor is the one that has really good data. Like pretty much an auto detects what kind of device that or what kind of data that you want to look at, and it can show that to you here. There is a basically an add-on store where you can like this is community generated integrations. So there's tens of thousands of like literally anything you ever could connect to, even if you like you do gaming, like you can have it so that when you log in and log out of Steam, it'll change the lights in your house. Like it'll literally do anything you could ever think of. So like if you wanted to do really cool Christmas lights, like I do that with Home Assistant, like to have it sync to music and stuff like that. It can actually be like a full music and media player for your house. Yeah, some of the add-on I don't need to go into those add-ons, but like for the original sort of proof of concept, I chose a couple of widgets here that would kind of show you in real time what the kind of temperature and humidity ranges are, like right on the map. This is a pretty crude way of doing it. There's actually a couple of plugins and I was just so many half-done projects where I was going to do a 3D visualization of the Falkland office, so that then you could do heat map interpolation of the different sensors, and then you could kind of like go through the history in real time of looking at, the different sensor readings, just kind of like pull it through like a timeline and be able to see whatever sensor reading you want. So if you wanted to do whether it's indoor air quality data or if it's the temperature data or the humidity data, you'd be able to kind of overlay it that way. The like up at the top here, it's just like this is I guess what you would call a badge, where I wanted to just put the weather badge here. All your weather data can be instantly kind of integrated, and they've got all these pre-made widgets for it. If you want to change something, if you want to add something, let's say if I want to add a badge that is related to the I don't want to do markdown, just actually give me there we go. So like the status of an entity. So, what is occupancy? Occupancy. And all these, it's like North Studio, is somebody home or not? And so you could then have we're going to have a much more beautiful version of this where we can kind of have all of these conditional badges and other things up at the top that can kind of tell you exactly what's going on in the house. Like these, as you probably saw as I was talking earlier, I just kind of hit a couple buttons and it was able to drop in the thermostat, drop in the historical graphs here. And then so if you set this up in kiosk mode, then it's like you can have it as a wall-mounted thing or something like that, with setting some, permission restrictions on it so that it can only, let's say on an Android tablet, the person can only kind of manage certain elements of the interface. You can create a user that's restricted for that purpose. So we're going to get to all that. We just haven't kind of executed on it so far. But let me just see if I take off my
While you're doing that, Aaron or Peter, do either of you have any questions?
Actually, I have a couple questions. It's
Okay.
Peter,
Hi,
and
Peter.
yeah, hi.
I have
I'm
for all my
going
things.
through permit process with my city of Oshawa in Ontario, and once they approve my building permit, I'm planning to build a passive house ADU, small ADU, and then I'm planning to use something like this. And thank you so much, Ben and Lori, for amazing presentation. And I can use a lot of information from this webinar. And my first question is, I think it's obvious, but I just want to confirm. So for the placement of sensor, so when you place the sensor, is it in the middle of ceiling or in the middle of wall thickness?
So if you're, I mean, where I put them was sort of towards the middle of the wall assembly, but on the sheathing for the roof. And that was because the sheathing is the vulnerable part in the roof assembly that I designed. And so that was why I did that. Like you could also, if you, I don't know if you were interested in something else like that, there might be another reason or another location if you had different reasons. So yeah.
I see.
Yeah.
Okay, that makes sense. Okay, for my second question is you mentioned that 20% sensors are not working right now, right? So is there any way you can fix it? What if that location is very critical and I really want to see the monitoring data for that location? Then is there a way you can fix now?
Well, there's
Yeah.
just kind of, yeah. Go ahead, Ben.
Yeah, so the troubleshooting exercise, because we did this with a couple that they had wired improperly, where there's a like the most likely culprit is that there's either a short or an open, probably an open wire from either at one of the junction points or else the wire itself was punctured. And so the process to be able to go fix it is to just spend a little bit more time specifically at the comms closet first, where everything was kind of pulled together into a kind of a into a single batch and hooked up to the RS-45 sensors. So I had already looked at that. That's how we fixed a couple of them, is that the wires hadn't been terminated properly. But the higher probability is that there might be a couple of like those two of those sensors. The wiring connection might actually be broken at the sensor location itself. So you have to cut open the roof, access the sensor, and inspect that termination point. But the other probable case is that the sensor itself is just during all the rest of the construction, the cable was damaged in a completely different area. And so the fastest way to fix that is that you'd have to rerun the cable.
I see. So you have to cut off the driver of that sensor location.
So,
Have
and
you, yeah,
I was going to say
yeah.
the number 8 is on the north roof, but it's in a part of the roof where there's more like a greater thickness of insulation. So I'm less worried about that one anyway. If something was going on in the north roof, I would expect it to be at that number 9 sensor. So I'm not really sweating that north roof one. And then the other one is actually the one we put in the basement. And that was just more like, oh, maybe we want to monitor the basement. I actually was just kind of like, initially I think I wanted 5 or 6 sensors and we got 10. So it was just kind of like, let's put one in the basement. So I'm not that one would not be very hard for us to, first of all, get, because the basement is everything's really accessible down there. But I'm not too fussed if we never get readings from the basement.
Okay, thank you. And
Yeah.
one last question. So other than the difficulty of coordinating with the contractor, would you say wiring is the most difficult part of implementing this system?
That would be that's my opinion. Yes. Like I have an IT background and I've been playing around with Home Assistant for like 6 years. So maybe I'm a little bit biased, but the wiring is absolutely the highest risk element because of like depending on when you do it in construction, and in this case, the unfamiliarity that the workers had with the technology and the purposes, is that it was just a little bit, it was outside of their scope. So yeah, I would say that the wiring is the highest risk, but the sensors themselves, like aside from that specifically those two that have been kind of having problems since the beginning, the rest of them have been very reliable consistently over the course of over the last year and almost year and a half that they've been installed.
I see. Okay, thank you so much.
So just last, like basically for as you guys can kind of see, I even have my car is a Kia or no, so it's a Hyundai where I can lock it and unlock it from here. My door is Bluetooth where I can lock it and unlock it from here. I can open my garage, from here. That's a custom ESP32 device that I have connected for the garage thing, but my robot vacuums, they're all integrated. And let's see, yeah, I've got like some of the stuff, like I actually have a little AI cluster that I'm running at my place that I don't even need to run my heat pump most of the time. because I'm using probably anywhere between 2,000 and 3,000 watts of of power on some of these devices doing AI inference. So just the level of customization and detail that you can have in this is just so much fun. So that's why I wanted to quickly just kind of show this off if you guys are kind of, data nerds.
Cool.
And I thought you were Bitcoin mining there for a second.
No, no, I never, I did Ethereum mining like back before anybody else. Like it was like maybe the first couple hundred people that were doing it. And I have an ETH wallet that has like a bunch of ether in it that I lost somewhere. And then I never touched Bitcoin or any of the other cryptos since then because it just, there's too much, too many other interests in that community that kind of confounds the actual value
Of
of it.
course. Well, I think it's so interesting that, in the last, I don't know, say 5 years of just kind of my building science career, that we went from, being aware of building science, building better assemblies, and now we're at a point where we're diving into the data. Um, and from, different people being able to involve it's fascinating just the real life data and just what we can do with it. And so I appreciate what you guys have done to to just get data, and then we have this conversation. It's so cool that a building that has lasted 100 some odd years is now going to last 200 plus years, and it can be tracked and tweaked and prodded and a whole bunch of stuff. So this is it's fascinating. So appreciate today's presentation.
Yeah.
And I do want to quickly go over this, if people would had a couple more minutes, is the Home Assistant data is pretty cool, but the way that I built this presentation is even more interesting. The way that I processed the data was even more interesting. It's not quite formatted super cleanly because I changed some of the fonts.
So you guys, to put some context around this, I told Ben in the maybe 20 minutes before we got on the call about the temperature spike, and he just got AI to like pull all of that together, like just while we were hanging out, chit-chatting. And so he was able to tell that story with the data that I was, telling as an anecdote. So yeah, it's pretty cool.
So a little background is that I've been working with basically I'm not a software developer myself, but I've been working with teams doing software projects for over a decade. I've been managing them. I've been doing a lot of the data analysis myself. I've had to do like manual ETL pipelines, which is like the evaluate, transform, load. It's about taking that whatever raw data you have and then putting it into a format where you can do the analysis and correlation with each other. And so, like very specifically for this project, earlier today, I basically did exports from Home Assistant, and I took those exports, they're CSV exports. I ended up using a Claude co-work session. If anybody here has used Claude, it's great as a chatbot. I don't use it as a chatbot though. I use it as basically a software engineer. Let me see if I can put this over here. So I ended up giving a very verbose prompt to basically say, this is, let me just get this back up. There we go. So this is what I want, is that I did a whole bunch of prep where I pulled out all the data. I took some of the email conversations that I had regarding this project relating to all of the kind of back and forth between trying to schedule things, some of the reports that I gave to Lorrie. And then I also provided a lot of context. And so I had a couple of files that said, like, here's the sensor locations. Here's a commentary on kind of all this information here. So I put that all in here. And then what it did is basically it's running its own little virtual machine that is creating all of these Python scripts, and it is leveraging, it's not just a black box, it is leveraging all of the industry standard data science principles that any data scientist or data engineer would use, where it built me like about a dozen or so Python scripts that did all of the transforms of the data. And then it did all these SQL queries to be able to kind of build out. First, I started with saying like, give me reports. So like, I want all of these various pieces of data that I have here. Give me reports of what is in this data that I provided to you. And then from that, I said, perfect. Now that I have a summarized version of all of this context, build me the slide deck. I gave it very explicit instructions on exactly. I didn't just say, build me slide deck, Mr. AI. Because I knew what I wanted the thing to be like, I just gave it, here is the kind of slide by slide, the information that I want to have in here. And then boop, it goes and builds it for me. So what I like about this is that it's auditable because I can actually go into the directory in Claude Cowork to be able to look at the Python scripts to validate that they're doing what they're doing. Because one of the things with AI is that it can hallucinate, right? And so instead of just dumping data into a ChatGPT session and saying like, just tell me what this data does, instead I kind of use a bit of a slightly different approach of I guess more similar to what an engineering team would do. And this is available to you. If you were to open up, like get a Claude subscription and then go into their Cowork tab, if you have a problem that you're working on where you have a bunch of data from various different data sources, and you just say, hey, I want you to normalize this data and then kind of go through an analysis to, give me some context about this and then ask it to do it in such a way so that you can audit the steps, because just blindly trusting the AI is still not the best idea because there still are hallucination attempts, or not attempts, but hallucination risk. But yeah, just in general, like the message that I sent that was related to that January cold snap. This was, yeah, like it was literally 20 minutes before the presentation that I was just like, hey, so we did all that data analysis. I have this one last thing is that here's the heat pump model. Here is the timeline. Give me 3 more slides. And then it goes through and it goes out to the internet. It finds the data on that heat pump. It goes back to my database. It does all the additional analysis of that. You can even kind of see here that not only did it take the outdoor data, but it looked at all of the weather events. So it went to 10, 20 different weather websites to be able to get that additional validation of it. And so what this unlocks is not only is Home Assistant open source that you can kind of deploy one of these Home Assistant devices for like $100 and then maybe an extra 50 to $100 for all the different sensors that you want to put in a project. But if you want to really get context from the data, these tools exist now and they're accessible. They're not that, like, I pay $280 a month for the max plan on Claude, which like I exhaust it. No, most people would never use that much usage, but because I basically spending most of my day in coding terminals, building out my local AI cluster with Claude. But just in general, I just wanted to let you guys know that this is the most interesting part about this data is that it's so accessible now to be able to go from the collection to the actual value that you can get from it. Because like I can even tell it to say that, hey, there are some additional dashboards that I want in Home Assistant that are related to building these building science principles. And then it would write me the configuration script that would build it out for me.
That's amazing.
That's so cool, Ben. Hey, Aaron.
Hey, great presentation and really cool really good work that you did, I think, on the home on the office Lorrie, as well as the presentation, Ben, and all the sensors. I think it's going to be really helpful work for retrofits in our area and in the industry. And it was interesting to see the Home Assistant application. I have a well server at home that was using for like 15 or 16 years. That's kind of in a similar way. It's able to monitor energy use and temperatures, but it died last year, and I've been looking at replacing it maybe with a Home Assistant application. So it was interesting to see this installation. It kind of reminded me the what you did here with what Keith Robertson, I think, did at Soltaire at his cottage, where he put some sensors, I think, in the walls of his cottage to kind of monitor how well the building operated over the winter and everything like that. But in terms of the project, I missed part of the presentation, so I guess yeah, you know that you have some humidity issues in your attic,
So
but is there a potential solution, or do you know what you're going to do with this? Or
well, so yeah, you might have missed the part. We actually know that there was a leak, like there was like some
okay,
water came in, and so I I could be wrong about this. My intuition, like any, and any modeling that, I've had people do woofy modeling for me before, where it was always like the north face of the roof was the issue, and even sometimes even like the north walls, like walls that don't get a lot of sun, roof faces that get less sun. Our roof is pretty shallow, so I was kind of curious whether north or south would make much of a difference. Like there's a low pitch on it. Um, but so you can see it's both kind of the south kind of roof sheathing, and then this south, I don't know where it's south hallway. I need to look at that one again. Is that
hmm
where my office is? That Ben?
Yeah, well, like where
Okay, you're calling
there's
it hallway,
this,
but yeah, okay, got it.
yeah, because
So
this is basically the one, like that's where you thought even before we put the sensors in,
yeah.
you're like, this is probably going to be a problem area,
Yeah,
and then
we
I don't have
we
the
like
picture of it,
definitely
but
put sensors around there because there
oh yeah,
so
this is your
there
office
had
right there.
yeah, that's my office. It looks way better now. Um, uh, there had been some water come in, and like it came in like sort of twice when it was at this stage, and we were kind of like, where the hell is it actually coming from? Because finding where the water starts
hmm
is such a problem. And so both times we thought that we addressed it, and I don't know if we had, I think we had like the problem in Halifax, and I'm sure it's a problem everywhere, but the directionality of the rain, right? Like we could have three rainstorms and it's fine, and then the fourth rainstorm, it's a nightmare, just because of the driving wind. And so we had a few more rainstorms and nothing happened. So we thought it was fixed, but then we did know that some came in because we saw water around a window. And so the
okay,
window at the back. And so we were like, you know, some swearing happened because it was insulated already. Um, and so there was supposed to be some more work, late fall, but then it just got to be too late. They couldn't do it. And so there's a little bit more work going to happen in the spring, potentially more than a little, which I don't want to think about or break to my business partner. But
hmm
yeah, so I don't think it's a dew point thing. I could totally be
right,
wrong though. So
right.
I think it's a bulk water issue.
Right. And you said you have some rigid insulation on top of the sheathing, is there, to help with
Yeah,
that?
so
Yeah.
there's tapered polyiso, like rigid, and it's so it at its shallowest it's 4 inches, and then it tapers up to whatever it is at the point. So off
hmm
of a flat deck. So there's quite a bit in the middle. But yeah,
Right.
yeah.
Great. Okay.
Yes, come see me. I'll tell you in, I don't know, 6 months how it went down.
Great. Thanks. I might be in contact with Ben then about the home assistant.
Yeah. Yeah. Well, thanks for coming out.
Thanks.
I
And
have one
thanks.
hands-on question,
Mhm.
just regarding the wiring, and you were mentioning about the complications and that being one of the more challenging aspects for the folks who did the install. Like, is it a simple, like a Cat 6 type wire that connects everything? Like,
It's
what would be a
not like
complex
extra,
part?
it's not super complicated. It's just that they were just kind of like, this is like an extra thing that we were, and
Yeah,
one guy really got it, and then the rest of them did not. That was the
right.
problem.
They were just unprepared for it. Yep.
Yeah.
And,
Not complex.
and they're just like running runs from every sensor back to some main control box. Is that
Yeah, you can actually, so with RS-35, you can daisy chain them.
okay?
And so that's the way that they, like I had provided the instructions of saying that this is what my recommended method would be. It was a combination of hub and spoke, like single fanning out to some daisy chaining. So it's pretty resilient. Like anything that's RS-45 is quite resilient and can withstand a large variety. Like some of these runs can be, over 100 meters long before you start kind of getting data qualities. But in our case, it was just that the physical cables, there was just too many miscommunications as they were executing.
Okay.
Yeah.
I mean,
I
yeah,
have to
a
shake
bit
my head.
well, it's state of the industry. It's like you just don't get the continuity because the trades are just flat out, and it's like we really want this guy to come, but he didn't, and
I just want people to care.
We've got continuity of insulation figured out, continuity of our air barrier and our water control layers. We can't get the continuity of our trades worked out yet. That's got to be the next one to advocate for.
yeah. Incidentally, the
It is
origin
tough.
of our roof issue was also that we had a roofing contractor that did about 75% of the work and then just never came back.
Oh,
And so then we had to get a second roof contractor, and they were like, oh, it's been a couple of months, so they kind of backpedaled it a little bit and then finished it. But I was always kind of like, it's not a good situation.
Yeah. Shoot.
Yeah.
I think, Lorrie, and one of the ways that the communication could be spun on this for the Nova Scotia, when talking to,
Mhm.
the other project stakeholders, is to kind of reinforce that need of like we have to be investing in the actual
Mhm.
training of these, because it doesn't matter how good you design one of these projects. It doesn't matter how much
Mhm.
effort you put into a simulation. It all falls down to that execution, and
Yeah.
because there are no real consequences like in residential trades, especially for kind of smaller buildings, anything that's not multifamily, everything falls apart. And
Mhm.
so the amount of money that's wasted, because I've looked at the, like I've gone through a lot of the data from the DOE about how billions of dollars worth of energy is wasted every year from residential homes just because HVAC systems weren't commissioned. That
Oh
has
yeah.
nothing to do with the envelope or like all the other characteristics, but like everything, like the sheer volume of wasted potential because our trades are unprepared for the energy transition. It is it is astronomical. And there needs to be a lot more effort put into that transformation side in the industry to make sure that not only the skills are there, but also the culture is there. Aaron,
I,
you are a part of ASHRAE. You are an engineer. That was one of the things. As soon as I joined ASHRAE, I'm like, holy crap! The divide between anybody in residential trades versus not anybody, but a lot of the residential trades versus commercial, like that is that's the root. It is just that the culture and skill gap, and I don't there doesn't seem to be enough effort into fixing that.
yeah. I think it starts with awareness though. We're veering into policy, which might keep us up far too late, but I do feel like there's training programs out there. They're just not quite hitting the mark yet. Not all, and there's some great ones, but like there there needs to be more investment for sure. Well, this has been awesome, you guys. I didn't even nod off. I thought I might, and I know it's like about my project, but this is awesome.
That's great.
Thanks for your great questions. And yeah, any like burning last words, anybody?
no, I just
No,
can't wait to see it in real life.
yeah, I just want to thank you guys for the presentation. It's really cool. I've been wanting to incorporate some of this stuff into my projects. And it's kind of like, we do all this work up front in the modeling and all of our building envelope and everything, and we kind of trust it. But this is another verification that we can have and understand, okay, hey, everything's telling us if we do it right, it will perform to this. But, this just tells us a little more in depth what's actually going on in those assemblies. So yeah, very cool. I'm sure I will be reaching out to Ben with some questions in the near future.
Awesome. That's the
Yeah.
hope.
Oh,
Yeah.
oh, I gotta run off to do some family stuff, but I am more than happy to follow up with anybody after this, and probably will be writing up some tutorials with Lorrie on like some other materials, so that I would love, like, it was since I found Home Assistant over the last couple of years, I'm just like, this could absolutely be a building science tool. So that's what I love out of this, is to have more people try it out in projects. And yeah, I'd love to help get that deployed. So I'm sorry, guys, I got to run. Thank you
That's
so much for
okay.
your time.
Thank you, Ben. Thanks for
Thanks,
your
Ben.
time.
You got to
Okay.
run too. So cool.
Yeah.
Awesome.
Thanks, everybody.
Have a great night, guys.
rest of your
Good night,
day.
everyone.
Hey.
Okay.
Thanks.
Bye-bye.
Bye.